Good afternoon, ladies and gentlemen. Today I'm doing a video on emergency lighting. So normally there's a little button on the side over here. Let me see if I can show you guys very quick. If you want to test emergency lighting, you just push this button down and your emergency lights come on, which is okay. But the problem is if you're by yourself and these heads are in multiple different locations, how do you test the momentary contact switch down and check all the lights throughout the building at the same time? Which you could go over and shut the breaker off, which is in the panel, which I think is this one here. Well, it's not that one. It's probably this one. No, it's not that one either. Then it leaves so much problems. You got to try to figure out which one controls the actual light. Then you're trying to figure out which breaker does it. So that's too much work. What I'm going to do, I'm going to install a switch on the box itself, so it allows you to just shut this off and gives you the simulation of no power. So basically how these things work, as long as there's constant power, the batteries will stay charging, and they continue charging until I want to find a good spot to put my switch. I think I'm going to put it like right here. I don't want to put it too far in the back because I got too many electronics back there. So I want to drill a hole maybe about right here. So basically I'm just going to put a regular toggle switch, like a little, not a regular, I guess you could call it a regular toggle switch. One of these switches, single pole, single throw toggle switch. On could be up, off could be down, if that's the orientation that we're going to use, like that. So I'm going to drill this hole just to get the hole started. Probably drill about right. Yeah, I don't want to be too close to the edge. I don't want to be too far in the back. I want to give myself no space. I don't want to hit any wires. So as long as I'm like right here, which is a safe, good distance, I should drill a hole. Should have safety goggles on, but almost there. Just a little bit more. Okay. Don't want to put your hands on that because you might get some metal filings. Just want to make sure that this hole is big enough for me to fit my switch in, which it is. What is the right size? So my next step is find out where the power is coming in and how am I going to interrupt it. Now, you might see these wires here and think, well, this is my negative, this is my positive. But look closely. The heads are coming onto these wires. So these are probably, looking at the batteries, they are 6-volt batteries because they're all coming off of each individual one. Well, we're assuming it's 6 volts because we don't know the battery size. Battery size is 12 volts, so it's 12 volts. So always look at the batteries, tell you what the heads are. So you might put the 6-volt head and burn out the head because you put the wrong head in there. So match the head, the bulb with the voltage on the battery. I'll always pay attention to that. So the other thing to pay attention to is primary and secondary. This is the primary side on this side, secondary sides on this side. This is not even tight either. That's weird. So now I know this is my 12 volts going out to my other local heads. These are my remote heads I have going throughout the building. These are my ones on the box. I got several going out throughout the building. What I'm doing, I'm just going to interrupt the primary side, which is right here. You see the black coming in and the white coming in, and you got your grounds over here. So you got your black, your neutral, your ground. All I'm gonna do is get me, looks like about 14 gauge wire here, which is sufficient because this is about 14 gauge wire here. You can go 12, which is a little bit bigger, but if this was on a bigger circuit, you always want to go the higher one up, never go the lower. So we're gonna just give this a little pinch and spin. Oops, dropped my little pliers there, which I shouldn't be doing. This is stranded wire, so it's a little more to strip. Not a lot, but you just gotta get that little casing off of there. You gotta peel that casing off and crimp it. Now I'm gonna put these on, so I'm gonna trim my wire back just enough to get this inside there and do that. Hopefully it fits inside the head. If it doesn't, then I get the wrong size crimp. That could be another problem. I should be using a thicker slot. Let's see how well this fits in first. Well, it looks like it's gonna fit in, so I think we're gonna be fine. Let's just force it in there nice and tight. If a little bit comes out on the other side of the head right there, that's not bad. I'd rather see the copper come all the way through than not know if the copper made it through. Like that little bit of copper is not going to interfere with your switch. So make sure this is all the way in now. Touching the insulation. Use my little crimp. I got my little crimper right there. This is not, well, you could use this one. This one's not really, well, it's kind of made for it in a way, but it's made for the bigger ones. But this one's good enough to crimp it down. Just take it, squeeze it, nice and tight. So I made my connection on that one. Now I'm just going to cut myself enough wire, which I don't need a whole lot, just to go from here to here. Maybe that much right there. I don't need a whole lot. Just enough to move this wire around where it's not going to be snug and tight. So that much there is good enough. Clip it and skin it. I tried not to do a lot of these videos because I'm at work, but my daughter was asking me to do a lot of these videos, and sometimes I can and sometimes I can't. You know, it depends on the time frame I have. So I just skin that. I'm making it look easier than it is. A lot of people have difficulty skinning this wire without nicking the wire because it's not, in reality, it takes a little practice to do. So I'm doing the same thing with another wire. Probably match them up about the same length. About the same length. You know, give it a little bit extra just in case. Zip it. I'm going to skin this back off here. About that much. I'm doing about a little bit over the length of my my pliers. See a little height right there? A little bit over that. Slightly pinch it. Get a couple of spins. So I cut the casing. Once I know I cut the casing, pull the wire off, and damn, right there. We just did it. No cuts, no scratches. You don't want to cut into the wire, because if you cut into the wire, you're pressing down on this too hard. You got to get a feel for this. This has many names. I call it side cutters. Some people call it lineman pliers. Some people call them dikes. There's a whole bunch of names they call these things. But just get the feel of it. You know, I'm just gonna pinch enough like that. Pinch it in there. Slightly pinch it. And I'm just shaving back the insulation, just like that, back, and kind of rock it back and forth. This is enough that you know you cut through. Once you cut through, just. I didn't cut all the way. Oh, I should have spun it all the way around. It's easy when you're not paying attention what you're doing. When you're paying attention, it's like it makes it look like it's harder to do. Okay, so we got that. Now, like I said, I want to make sure I got enough space I can get this through, which I do. I'm going to trim a little bit off because I think I might have too much going through there. So just trim a slight bit off, not a lot. Just a little pinch, like maybe about that much right there. Take it, pinch it off. Okay, we the better side of the cutters off now. Now, I'm gonna get this all. This is stranded wire, so you want to make sure you keep all your braided edges all together. Now when I put this in, I'm kind of doing it in a rotation motion, slightly pressing down at the same time, slightly pressing while I'm spinning, a little bit more, I want that thing to seat all the way down. I don't want to see any copper through the other edge. Now I know I went through because I see the copper at the tip of my finger, so I know I made it through. Now when I put my crimp on it, I know that I'm crimping on some copper because I'm all the way through. Now everybody has a different technique. I don't think there's any right way or wrong way. The most important thing that you do it efficiently. I mean, I guess there could be wrong ways. If you are 100% just do it not the right ways, that would be considered the wrong way. Now I'm going to put my switch, assuming that this is on and off, because the thing only could go one direction. So if I'm looking at the decal, this is on, this is off, I want it facing in that direction. You can't spin it around because it's a little slot that won't allow you to spin this around. So if that is the correct way, slide it in. Now I'm doing this with the power on, guys. So like if you don't feel comfortable with, you know, the power being on, by any means kill the power. Do not work with electricity, because you got to respect it. If you don't respect it, it won't respect you. I'm doing it with electricity on because I'm so used to doing it that way. And I always do my last connection over here, so I do all my final connections here. And this is all my safe area. This is what we'll call unsafe area. So these are all just plugs in. They just plug into the back, male or female, basically. Just gonna plug this in nice and snug, if I can get it in there. Here we go. One's in. Gonna plug the other one in, right here. Just make sure you get it straight. You don't want to put too much pressure on it and over push. Always take your time. Make sure you line up these little. There we go. Just push it nice and tight. So it's snugged on there. Now, I know this is my live side. So if this is my inside, this is my live side over here. This is my dead side over here. So what I'm going to do, I'm going to disconnect this. Now these lights are going to come on once I disconnect this because it's no longer going to have power. So once it has an interruption of power, lights come on automatically. That's the relay switch inside that's going to turn this on. So once I disconnect this, lights should come on automatically. If they don't, then it's not working properly. Okay, lights are on. So now we know that's working. Now I'm going to take one of these wires, doesn't matter which one because it's only interrupting. We're going to wrap this up nice and snug. I'm going to have to cut some of this wire off because it might stick out the bottom because based on the size of this cap. Well, maybe not. We'll see. I have to snip some off, but as long as I don't see any copper, which I do see copper, and I don't want to see copper sticking out the bottom because that's not good. So I'm going to snip off just this much right here. Snip that off. Make sure this is nice and snug. Now, a lot of guys don't twist the nuts, the wires when you put them on. You should twist these. Always twist these. That gives you a secure bond. Some people just stick the wires in and spin them. You can do that, but it's not guaranteed that you're going to have a nice, snug, tight connection. So you want to make sure you get it all the way in. Don't have to really wrap them with tape as long as you don't see anything coming out. Give the wire nuts a little tug. If they come off, then they're not on properly. Okay, now this was an orange wire nut. I'm gonna get rid of this orange wire nut and put a yellow one on because I don't like to put. I could have used the orange nut, but I'd rather use the yellow ones. The yellow ones give you a little more security because they got the little hood that goes over the extra wire. Now we're taking the next wire because we did one. Now this is the second one. Now keep in mind this one's live. Now you can touch it. You won't get zapped. You won't get zapped. You just can't be grounded. You can't be touching something else while you're touching that. Or if you touch like this, you will get the zap, but you get it through your hands, not through your body. There's a bunch of other stuff to go along with that, but we're not going there right now. Keep your wires together. I want to I want to snip a little bit off of this because it's a little too high. So I'm going to snip a little bit off. That's why I say always cut more and cut back later than have too little and try to add. If you try to add wire, then it makes it harder. So always give yourself more wire and take it off at the end. Because it's easy to take it off and try to add it on. Trust me, try to add it on, it makes it a whole lot different. So now, I'm going to snug these up nice and tight. Okay, so now, we're nice and snug. No copper coming out of there, which is good. No tug. I'll stick these wires nice and tight in the back. Activate my switch. Lights are going to go off. Now I can test my lights. We had an electrician come out. Well, I'm an electrician too, but we paid an electrician to come out to put a switch in like this. And he put a toggle switch, like a regular light switch like this. I don't know if you can see that light switch up here behind his head. But he put a light switch like that. And the price that he put that switch in, I think it was around $185. A box like this, 4-inch, what you call it? This is the connection box, junction box. We'll call it junction box. 4-inch junction box. A regular up on and off toggle switch. Ran about, we'll say maybe 2 feet of wire because he put the box on the outside of this cabinet. And I was like, wait a minute. Yeah, you charge $185 to do this. So, bought these switches here. These switches are probably, I don't know, the company paid for it. The company probably bought these for like, probably $4. $4. We'll say $5. We got a few of them because we're going to do multiple different buildings. So I got this one here. I got another one. I got another one here. I think I got another one over here. So we're gonna be doing a few of these around the building. Got us some wire. This is 14 gauge wire. It's about maybe it was about 10 feet. I probably took off about 2. Who knows? So all that material might only came up to maybe, let's say $10, if that. Maybe let's say $20. We don't even know. But the time it took me to put this in was less than 15 minutes. Whatever how long this video is. No cutting, no editing. Same results, cheaper price, better job. I don't know if you guys can see this, but that's where my switch is right there. My switch is right there, where I want it to be. This normally would be this switch here, but you have to hold it down for it to actually like stay on. You will have to do this number and walk around the whole building, test all your heads. Or you have one guy down here shutting off the breaker, leaving that breaker off. Who knows what else is connected to it. So I always say think smarter and don't work harder. You know what I mean? Like, so it's simple. You know, anybody can do this. Like, it's no rocket science whatsoever. Only thing I suggest, if you're not comfortable with working with the power on and you don't know the full theory behind electricity or even know a little bit about electricity, I say shut the power off. It may take you a little while to figure out which breaker it is, but it's best safe to not work with the power on unless you feel comfortable. I feel comfortable with it because I've been doing it for so long. You know, it is what it is. This I'm gonna tighten this up, but that's definitely loose. I don't know why that's so loose. Every time I see something like that, it just bugs me. Like I'm not a perfectionist, but I just like to have stuff. That's got a whole spin on there. Another spin. There we go. Now we're tight. These things are supposed to be snug. That theoretically, this is part of your ground. If this was an armored cable, this would be part of your ground. Because it's non-metallic cable, it's not really part of the ground, but that still has a purpose of it being snug. They shouldn't be loose. These connectors should not be loose at all. So once again, I'm Neza Porter, just doing a quick video on how to change, or I should say add into a switch that you normally would not have. Now, all the switch does is just interrupt these two wires. It interrupts these two wires right here. It either opens it or closes it. Right now it's closed because obviously the power is coming through, the lights on. Once I open the switch, the lights come on, boom, emergency lights are working. So much easier, less headache, less everything. I got 3 more to do, and I hope you guys enjoy this video. I'm gonna start doing a lot more of these videos as I can. Like, I do various different things between electrical, plumbing, little carpentry here and there, a little bit of everything. Mostly electricity, but it doesn't matter. If I can do it, I'll do it. So we're out of here on this one. This one's all buttoned up. Work order complete. Until next time, guys, I'm Nez Porter signing out. Hopefully you enjoyed the video. If you see anything I did right or anything I did wrong, leave some comments. I know I'm not 100% perfect on all this stuff. There's probably some steps I could have explained more detail, but if I didn't, let me know. The next time I do another video, I might put in more detail. Some people would wrap tape around this. I choose not to wrap tape around it because they're spaced out, and if these 2 wires do connect, all it does is just make the circuit close. There's nothing else in this way to interfere with it that would cause it to be a short circuit. So I choose not to wrap tape. Not that I don't have tape. I do have. Electricians always carry a roll of tape, but I choose not to put tape around it because there's no real need to do it. Some people put shrink wrap around it, do a whole bunch of different things. It's no right way, wrong way. Or the right way would be doing it where it's not interfering with a whole lot of stuff. It's not, put in the area where it's not going to be causing a problem, basically. Make sure your wires are not rubbing up against anything. The most important thing with these wire nuts, you don't want to see any copper, no copper at all coming out of there. You could wrap tape around them if you want to, but you don't have to. I don't wrap tape around because I usually make sure I have a good connection. And part of having a good connection is twisting the wires first, then putting the wire nut on, make sure it's nice and snug and it doesn't fall off. If I go like this and this wire nut falls off, then I have a problem. I think that's about it, guys. Make sure all the wires are in, nothing's obstruction. Remember, primary side is always your high voltage side. Secondary side is always your low voltage side. This also is switching from AC to DC. So this is the AC side, which is alternating current. This is the DC side, which is direct current. There is a transformer that steps it down and converts it over as well. So it does 2 different things. It steps down the voltage and converts it over to DC. Sometimes you have a regular doorbell transformer which just steps down the voltage from AC. It's still AC to 24 volts or 16 volts. So that's a whole lot of other stuff to try to explain, but always know your primary side. If you're not too sure, get a tester, a multi-tester, anything to check out your wiring and make sure you got everything properly in there.